Hello everyone. In this video lecture, we will discuss how to do your lab number 7 on control system. So basically, this lab is to verify the effect of input waves, loop gain, and system type upon steady state error. So we already discussed this in previous videos. So basically, we want to look at the steady state using MATLAB. So for this lab, you need a MATLAB and Simulink, which also have control toolbox added in it. So before starting lab, so you have to go through the basic concepts about what is steady state error, what is the loop gain, what is system type. Okay, so pre-lab is first of all you have to answer this: what system type will yield zero steady state error for step input? So as you know that when you give a step input and you get steady state error 0, it is only possible when you have integral, a single integral at least. So similarly for ramp you have two integrals and so on. So these five questions, you can easily answer these if you go to your book on page 353 on normalized. There's a table. You can use this table to answer the question. For example, we look at the step input and type 0, so you have a constant error. But if you look at for type 1, you have 0 error. So type 1 means you have a single integral. So you can answer the first question. Similarly, second question: what system type will yield 0 steady state error for ramp input? So of course you have at least two, and this is for type 2, where you have two poles at the origin. Okay, so similarly you can answer the third question: what system type will yield infinite steady state error for ramp? So look here, infinite steady state error for ramp input. So this is your ramp input. So look here, this is infinite error. Okay, so this is for type 0 system. Right, now the next question is what type system type will yield 0 steady state error for parabola input? Again, for 0 state for parabola, you need at least how many poles? 3 poles at the origin. So it is type 3 system. Okay. Now the last question is what system type will yield infinite steady state for parabola input? So of course type 0 and type 1 gives you infinite error. So this table will actually answer pre-lab questions. Okay. Now from question number 6 and 7, it says that you have this feedback negative scenario and this is the block diagram. So to solve this for 6, 7 and 8, I recommend you to do first example on page 347, where you have to calculate the steady state error. So if you are struggling how to find it, so just go to page number 347. Okay. So, for example, this is skill 1. You can do this thing. If you solve this, you can easily solve 6, 7, 8 question in the lab. Or you before this, you can solve this example 7.3, where you have the same type of inputs and same type of system is given. Okay, so you can solve these three very easily. When you do that on your paperwork, so after that you answer these things. Now the next thing is you have to verify this in MATLAB. So then lab starts. So you have to use the Simulink and set up negative feedback. You have to make a system with negative feedback. So you have to do for pre-lab 6. So you already calculated the steady state. Now you just put G here and H here in the simulating, give a step input with 5 amplitude and see the output results. Now the thing is, you have to look for the steady state error. How you make the error? You just make a summation here, or just pick a scope at this point. Okay, so this is the error, this is the output, and this is the input. So your error will be here before GFS, and this gives you the error. So this way you can see it, and then you have to compare the result you are getting your pre-lab and verify by the MATLAB. Similarly for second and third. So these three questions are actually verified using the MATLAB. Now after completing this, now the next thing is post-lab. So then you have to answer, uh, is there any difference between pre-lab and post-lab? So you have to answer these questions, and you can do it very easily. So the main idea here is to solve this lab. I recommend you to go through these examples and also use this table. If you know that what is system type, how you calculate the steady state error for step ramp, then you can easily solve this lab. So the basic idea for this lab is to use the concept that you studied uh, in this chapter and implement online. So this is the table that can help you a lot. I will stop here. If you have any question, you can ask. Thank you.